Here we go with lesson 7 of the Earth topic. Please remember after the lesson to go back to show my homework, click on the entry for lesson 7 and complete the 10-question quiz. Here's a quick starter before we get going to check your understanding of some important chemistry keywords. So pause the video, don't write this out, just think to yourself and match the numbers and letters. Pause it now. Here come the answers. Let's go through the keywords. An element is made of one type of atom only. A compound is made of more than one type of atom bonded together. If a substance can be easily separated, it is a mixture. A chemical used up in a reaction is called a reactant. A molecule is a small group of atoms bonded together. Oxidation is a reaction with oxygen. A hydrocarbon is a chemical made of carbon atoms and hydrogen atoms bonded together. And a product is a chemical made as a result of a chemical reaction. Now, last lesson we were looking at how methane can react with oxygen to produce carbon dioxide and water. Methane is a useful fuel which comes from the earth. There are other hydrocarbons which are useful, like petrol and diesel, which also come from the earth. But in today's lesson, we're going to answer this question: do all reactions give out heat energy? And we're going to introduce some new keywords, exothermic and endothermic. So thinking back to last lesson, with the Bunsen burner reaction of methane gas from natural gas in the Earth's crust, separated into methane and other gases, the methane gets piped into the classroom, then it reacts with oxygen from the air. And when that reaction happens, when methane reacts with oxygen, it produces carbon dioxide and water. And we learned that is because methane is a hydrocarbon made of hydrogen atoms and carbon atoms bonded together. The hydrogen joins with oxygen to make H2O, water. The carbon joins with oxygen to make CO2, carbon dioxide. So this reaction of methane and oxygen makes carbon dioxide and water. At the same time, heat energy is released into the surroundings. That heat energy comes from the fuel, in this case methane. Fuels contain a store of chemical energy. When they react with oxygen, that energy is released in the form of heat, and the heat energy is transferred into the surrounding area, and we feel that as heat temperature. Okay, so as well as making carbon dioxide and water, the chemical energy inside the fuel is changed into heat energy, and the heat energy is released into the atmosphere. So some reactions, like a Bunsen burner, give out heat energy. Here's an example. In school, we would do some demonstrations. Here's one that different teachers recorded. So in here is a reaction. Let's see what happens when the reaction gives out energy. There we go, lots of heat energy being given out during that reaction. Now, some reactions do something different. Here's a reaction. Instead of giving out heat energy, this needs to take in heat energy. So the Bunsen burner is going to go underneath this chemical to continuously heat it. And this reaction needs to take in a lot of heat energy to make the reaction happen. Let's fast forward that a little bit. Let's get the Bunsen burner underneath the chemical. This is copper carbonate. You will have learnt in a previous topic that when it gets heated, it does thermal decomposition. It breaks down into copper oxide and carbon dioxide. But today we're concentrating on the fact that this reaction needs to take in heat energy in order to make it work. So there we can see a new product being made, a black powder. There's some carbon dioxide gas being given off as well. So as the products get made, in order to make that happen, the reaction needs to take in heat energy. So some reactions give out heat energy, other reactions take in heat energy, and we have two keywords to help us summarize that. Now, they both contain therm. Therm means heat energy, as in thermometer. A thermometer measures temperature. Okay, so therm refers to heat, temperature, or heat energy. Right, now exo means exit. So the heat exits the reaction. Right, so heat energy is exiting the chemicals. And that we call that exothermic. So when a reaction gives out heat energy, the heat is exiting the reaction, exothermic. Right? So an exothermic reaction is when heat energy is given out by a reaction. Heat energy exits the reaction. Endothermic. N refers to enter. Heat energy enters the reaction. So in an endothermic reaction, the heat energy needs to go into the chemicals to make the reaction happen. Heat energy enters the reaction, endothermic. Okay, so we have these two keywords. Exothermic means heat energy is given out by the reaction. Endothermic means heat energy is taken in by the reaction. Now, in an exothermic reaction, when heat energy is given out, you see the temperature go up. But in an endothermic reaction, when heat energy is taken in by the reaction, it needs to absorb that heat energy. Now, sometimes it absorbs it from the surroundings, and that causes the temperature to fall. So if a reaction gets cold, that is a good clue that it is endothermic. Heat energy is being taken in by the reaction. So there are two types of endothermic reactions, ones which need continuous heating, and others where the reaction gets cold because it sucks in heat energy from the surroundings. Right, so let's summarize. Exothermic gives out heat energy, temperature increases. Endothermic takes in heat energy, sometimes the temperature decreases. Right, pause the video, and the question you're going to answer is, or we've got a series of questions, is each one exothermic or endothermic? So I'll put them all on the screen, and for each one, can you please say whether they are, you don't have to write it down, just think in your mind, is it exothermic or endothermic? Pause the video and decide your answers. Here we go. The first one, temperature rises, temperature's going up, it's exothermic. If temperature falls, it's endothermic. If heat energy is taken in, we call that endothermic. Heat energy is given out, that is exothermic. In number 5, the temperature is going up. That means it's exothermic. Heat energy is being given out by the reaction. In number 6, the temperature is going down. Heat energy is being taken in. It is endothermic. Right, in your own words, pause the video and think of a sentence. If there's somebody in the room, say your sentence out loud. See if it makes sense to them. Pause the video. What is an exothermic reaction? Let's have a look at my answer. I said an exothermic reaction is a reaction which gives out heat energy. The temperature increases during the reaction. Right, then let's do the other one. Pause the video and in your own words, what is an endothermic reaction? Pause it now. Let's look at my answer. I said an endothermic reaction is a reaction which takes in heat energy. The temperature decreases during the reaction. The other option for endothermic is it needs continuous heating. Okay, now in school we would do an experiment, get you to do some investigations and measure the temperature rise. And if the temperature goes up, it's exothermic. If the temperature goes down, it's endothermic. We can't do that by video over the internet, so we're going to skip over this and have a look at the results in a minute. But here's a couple of examples of reactions. So think to yourself, if your teacher was demonstrating this, would you think it was exothermic or endothermic? Do you think the temperature is going to go up, or is the temperature going to go down? If temperature goes up, it's exothermic. If temperature goes down, it's endothermic. So have a look at this reaction. This is one you've seen before in the past, but here's a video of it. Would you say exothermic or endothermic? Okay, now I would say exothermic reaction. Heat energy is being given out. Let's have a look at the next one. And would this be exothermic? Oh, it says giving away the answer. This is an endothermic reaction. Right, so let's have a look at the evidence for that. What evidence is there in this video that this is an endothermic reaction? Have a look. There's water being squirted onto this block. Okay, then the two chemicals are going to get mixed. It takes a bit of stirring, right, and then it gets put onto the water on the block. Right, now the temperature drops. Okay, the temperature is going down, and that freezes the beaker to the block. So the water in between freezes, and that sticks them both together because it's getting very cold very quickly. Do we call that exothermic or do we call that endothermic? What would you say? It is endothermic. If the temperature goes down, it is endothermic. Now then, why does it happen? We're going to go into more detail thinking about energy and energy transfers. All chemicals contain chemical potential energy. fuels like methane or petrol or diesel, a fuel has a store of energy inside it. Sometimes we call that chemical potential energy. So chemicals have energy inside them. Now, when a exothermic reaction happens, that chemical energy is converted into heat energy, and that heat energy is transferred into the surroundings. So some of the chemical energy changes into heat energy as the energy gets transferred into the surroundings. So if we put a thermometer close to this reaction, the thermometer will go up because heat energy is being given out. But that's being given out because chemical energy changed into heat energy as the energy got transferred into the surrounding area. Okay, heat energy is given out. Now, in an endothermic reaction, before the reaction happens, or to make the reaction happen, heat energy needs to be absorbed from the surroundings. So the reason why an endothermic reaction gets cold is because heat energy is being sucked into the reaction. So heat energy moves into the chemicals. That is then stored in the form of chemical energy, chemical potential energy. So the chemical potential energy will increase. The chemicals gain energy. They absorb it in the form of heat energy and store it as chemical energy. So energy is transferred from the surrounding area into the chemicals. So it looks like the temperature goes down because heat energy is moved into the chemical. Okay, right. So this increases the store of chemical potential energy inside the chemical, but it came from the surrounding area as heat energy was moved into the reaction. Okay, pause the video again. Read these 4 descriptions. For each one, say if they are exothermic or endothermic. Pause it now. Here we go once again with some answers. A was exothermic, temperature rise, temperature's going up, it's exothermic. Reaction B, the temperature's going up, exothermic. Reaction C, the temperature went down, endothermic. Reaction D, the test tube got very warm, the temperature must be going up, it's giving out heat energy, it is exothermic. It is time for the writing task in this lesson. Really important now to write it down in your own words. We try and keep the writing to a minimum in the first part of the lesson so that you can concentrate on writing in this part of the lesson. Here's some sentence starters to help you. So we've got our new keywords for today, exothermic and endothermic. What do they mean? Then explaining how temperature can be used to decide if a reaction is exothermic or endothermic. Then I filled in the results of the experiment. You need to work out the change of temperature and then use the fact of whether it's going up or down in order to say whether it's exothermic or endothermic. Then combining in the idea of energy transfer, chemical potential energy and heat energy to explain why some reactions are exothermic when others are endothermic. Pause the video for as long as you need. And use the sentence starters, always write in full sentences. This is where you need to put really good effort into your writing task so you end up with a good set of notes which shows correct science understanding. So pause the video for as long as you need to complete the written part of this lesson. Go for it yourself. Okay, I hope you've given that a really good go. I'm about to move this onto the answers. Remember to tick work that is correct and feel proud of yourself for getting science work correct and feel proud of yourself for your effort and for trying to extend yourself and do the best that you can. Remember to add in anything that you didn't think of as you are marking it. An exothermic reaction will give out heat energy. An endothermic reaction will take in heat energy. If you've already written about the temperature going up or down, that's a really good thing to include. I've included that in this green section here. We can use temperature to decide if a reaction is exothermic or endothermic by looking at whether the temperature goes up or down. If temperature goes up, the reaction is exothermic because it is giving out heat. If the temperature goes down, the reaction is endothermic because it is taking in heat. Using the word because helps to make our writing into an explanation. Okay, the results of the experiment. You can see the temperature changes here. A, temperature rise of 33, exothermic. B, temperature fall of going down by 13, endothermic. C went up by 9, exothermic. D went down by 4, endothermic. E went up by 23, exothermic. Okay, right, so to summarize, A, C, and E are giving out heat energy. The temperature increased, they are exothermic. Reactions B and D took in heat energy. The temperature decreased, they are endothermic. Then, combining in ideas about energy transfer, reactions that are exothermic transfer heat energy into the surroundings. They do this by converting chemical potential energy into heat energy, which is then released to the surroundings. Some reactions are endothermic because they absorb heat energy from the surroundings. They do this by converting heat energy into chemical potential energy, which is stored inside the chemical. And please remember, there are two types of endothermic reactions: the ones which absorb heat energy and the temperature falls, and the ones which need continuous heating with a Bunsen burner in order to supply the heat energy which they need to absorb. But all of that heat energy gets changed into chemical potential energy and stored inside the chemical. Today I achieved describe, because I can describe the meaning of exothermic and endothermic. Explain how to decide if a reaction is exothermic or endothermic. Use results from experiments to decide if it's exothermic or endothermic. And combine, because I could explain why some reactions are exothermic when others are endothermic. Whatever you have achieved today, well done for your effort and for doing your writing task. Please do remember to show somebody at home what you've achieved so that they can feel proud of you for keeping up with your science work. Well done, Year 7, great work. Please remember to go back onto Show My Homework, click the Show My Homework entry for Lesson 7, and then do the 10-question quiz about that lesson. Well done for your work today, and we will do another lesson. Lesson 8 will be about combustion reactions, so look out for that one. See you soon. Bye-bye. Well done.